Okay, so we're looking at commutative property. Everything we learned, everything we learned today is going to be about these properties of addition and subtraction rules. So the first property of addition is the commutative property. Its nickname is the switcheroo property because no matter what order you add numbers, the answer is the same. If we look at the examples, 2 plus 3 is the same as 3 plus 2. Class, what is 2 plus 3? Class, 6. What is 2 plus 3?
6.
5.
Class, what is 2 plus 3?
5.
5.
What is 3 plus 2?
5.
What is 10 plus 12? I'll tell you a really
22.
easy way. What's 2 plus 0?
2.
2.
What's 1 plus 1?
22.
What's 1 plus 1?
2.
So 10 plus 12 is?
22.
22.
Now 12 plus 12 plus 10. 2 plus 0 is?
22.
2 plus 0 is?
2.
1 plus 1 is?
2.
12 plus 10 is?
22.
22. Now we can do 16 plus 11. 6 plus 1 is?
7.
1 plus 1 is?
2.
2.
16 plus 11 is?
22.
16 plus 11 is?
26.
16 plus 11 is?
27.
10.
11 plus 16. What's 1 plus 6?
7.
7.
1 plus 1.
2.
11 plus 16.
27.
27.
9 plus 4.
13.
4 plus 9.
13.
So we can see that the commutative property, it does not matter what order we add the numbers in, the answer is going to be the same. Circle the word ordered on your anchor chart. This is the key word when trying to figure out what property is being used. If you see the word order, you are probably talking about commutative property. Because commutative property says no matter what order you add the numbers in, the answer is the same. That's whether we have 2 add-ins, 3 add-ins, 4 add-ins, 5 add-ins, 6 add-ins, 100 add-ins. No matter what order you add them in, it's going to be the same. Okay, helper number 2. Please sanitize, erase, sanitize. Okay, go ahead and look at the page that says associative property. Look at the page that says associative property. Associative property is called the friendship property because no matter how you group the numbers, remember if you have friends, you usually have friend groups. Maybe your friend groups can get together. Well, that's what the associative property is. No matter how you group the numbers, the answer is the same. So we can see if we have 1 plus 2 plus 3, we get the same answer. So, okay, 1 plus 2 plus 3. We grouped the 2 plus 3, which is 4. 1 plus 4 is 5. So in 1 plus 2 plus 3, this first one, we put 2 and 3 in a group. Now, if we come over here, we have 1 and 2 in a group. We have the same add-ins, but now 1 and 2 is in a group. Well, 1 plus 2 is 3. Oops. Sorry.
Yeah, that's supposed to
2
be
plus
5.
3
It's
is 5. 1 plus 5 is 6. Now over here, we grouped 1 and 2, and 3 is by itself. 1 plus 2 is 3. Plus 3 is 6. If we look at 8 plus 5 plus 4, well, in the first equation, we have 5 plus 4 in a group. 5 plus 4 is 9. 8 plus 9 is 17. In the second equation, we still have 8, 5, and 4, but this time 8 and 5 are in a group. 8 plus 5 is 13. Plus 4 is 17. So we have 17 on both sides, no matter how we group the numbers. Over here, we have 7 plus 9 plus 2. In both sides, we have 7, 9, and 2, 7, 9, and 2. In the first equation, we grouped 9 plus 2. 9 plus 2 is 11. 7 plus 11 is 18. In the second equation, 7 plus 9 is 16. Plus 2 is 18. In the last set, we have the numbers 6, 4, and 3 on both sides. In the first equation, we have 6 plus 4 in a group. 6 plus 4 is 10. Plus 3 is 13. In the second group, in the second equation, we have 4 plus 3 in a group, which is 7. 6 plus 7 is 13. So we see, no matter how you group the numbers, the answer is the same. So put a circle or a box around that word group. Also, if you see parentheses, you're probably working with associative property of addition. Now these are all properties of addition, not subtraction, not anything else. Okay, now look at identity property. Look at identity property. Make sure your paper's on your desk. The identity property is also called the all about me property because it's all about 0. Whenever you add 0 to any number, the sum is the same. So whatever number you're adding 0 to, that's going to be the sum. 4 plus 0 is 4. 13 plus 0 is 13. 26 plus 0 is 26. 9 plus 0 is 9. Now this is going to make it easier for you because if you ever see a number plus 0, you automatically know, I don't even have to do any math, I know the answer is going to be the same. So the key word for the identity property is add 0. If you see add 0, you know you're working with identity property because when you add 0 to a number, the sum is the same. Okay. Ethan, or helper number 1, please sanitize, erase, sanitize very quickly. And everybody look at subtraction rules. Yes, Helen, quickly.
Do you mean 0 from holes?
What?
Do you mean 0 from holes?
I mean the digit 0. Quickly, Ethan. Otherwise I have to do it myself or get helper to do it. You should be done by the time I get up front. You should be done and moving back to your seat by the time I get up front. Just set it down. Okay, so now you should be looking at the sheet that says subtraction rules. Just like there are addition properties, there are subtraction rules. There are not subtraction properties. So if you have a question where you have to identify and you tell me it's a subtraction property, that's not true. So there is one subtraction rule, and it's called zeros in subtraction. So underline that because that is the name of this subtraction rule. It says, excuse me, when you subtract 0 from any number, the difference is always the same as the minuend. Minuend is the first number in a subtraction sentence. Subtrahend is the second number in a subtraction sentence. Difference is the answer in a subtraction sentence. So the zeros in subtraction rule says anytime you take 0 away, the answer, the difference, is the same as the minuend. 22 minus 0 is 22. 14 minus 0 is 14. Zeros in subtraction also says when you subtract any number from itself, that means your minuend and your subtrahend are the same, the answer is 0. So again, when you subtract any number from itself, the difference is always 0. 16 minus 16 is 0. 20 minus 20 is 0. Okay, so go ahead and put those anchor charts to the side. Get out your math book. And you can go ahead and open to page 61. So again, anytime you see a key concept box in a math lesson, or really any lesson, it needs to be memorized. So let's look at this first one. It gives us each addition property in words and an example, which means in numbers. So, in words, what is the commutative property of addition? Colin. Loud and slow.
Commutative property of addition. The order in which number are added does not change the sum.
So again, we already knew that because we had it on our anchor chart, but put a box, a circle, whatever you need around that keyword order. If you're working with the commutative property, you're working with the order. Now, Cullen, tell me in numbers what the commutative property looks like.
1 plus
You got to start in order.
4 plus 1 equals 5.
So 4 plus 1 equals 5. What else?
1 plus 4 equals 5.
Good. So it doesn't matter what order we add them in, it's going to be the same. Like I said, whether there's 2 numbers, 8 numbers, 157,000 numbers in your addition sentence. No matter what order you add them in, it is going to stay the same. Thank you, Cullen. Now, the associative property of addition. Victoria, tell me in words what the associative property of addition is. Louder. No, just be loud, like you're screaming almost.
Associative property of addition, the way in which numbers are grouped when added does not change the sum.
Good. So again, we see that keyword grouped. Because anytime we're working with groups of numbers, we know we're working with the associative property. So Victoria, give me that first example. What are our add-ins? Remember, add-ins are the pieces of an addition problem. Just tell me what the digits are.
5,
Louder.
5 and 2,
Is that it?
5 plus 2,
Tell me all the digits in that first problem.
and 3.
5, 2, and 3. In our first problem, we have 5 and 2 in a group. What did we end up with as our answer? 10. Because remember, parentheses mean you do that first. Whatever's in parentheses, you do that first. Do you remember that from last year? Whatever's in parentheses, you do that first. So, in our first equation, we have 5 and 2 in a group. Our answer was 10. In our second equation, what are our add-ins? 5, 2, and 3. We have the same add-ins. But this time, we have a different group. What's in a group this time? 2 and 3. Did our answer change? It was still what? 10. So again, doesn't matter how you group the numbers, they're going to stay the same. The answer is going to stay the same. As long as your add-ins don't change, no matter how you group them, the answer is going to stay the same. Okay, identity property of addition. Carla, tell me in words what the identity property of addition is.
The sum of any number and 0 is the number.
Good. So the sum of any number and 0 is whatever number is not 0. So again, we have our keyword, or number in this case, which is 0. So, Carla, tell me in numbers the first example that we have.
8 plus 0 equals 8.
8 plus 0 equals 8. Our sum is exactly the same as the number, as our add, the sum is exactly the same as our add-in that is not 0. Okay, Carla, give me the second example.
0 plus 8 equals 8.
Good. So again, our answer, our sum, is the same as the add-in that is not 0. Ooh, can anybody tell me what other property they see in these examples? What other property do you see in this example for identity property of addition? Colin? Commutative, because in the first problem we have 8 plus 0. In the second problem we switched them and have 0 plus 8, but our answer stayed the same. So with these examples, they gave us two properties. The identity property, because any number plus 0 is that number, and the commutative property, because it doesn't matter what order the numbers are added in. Okay, helper number 1, sanitize, erase, sanitize. Everybody else, go ahead and look at example 1. So finger or pencil. Okay, so finger or pencil on example 1. Read in your head while I read out loud. Carlos is buying the items shown. Does the order in which the numbers are, does the order in which the musical instruments are scanned change the total cost? So if you're at the grocery store and you know that something costs this much and another thing costs this much, does it matter what order the cashier scans it in? Well, let's see. So he's buying a triangle for $10 and a drum for $20. So let's see. On this first side of the equation, they scanned the triangle first, which was $10, and then they scanned the drum, which was $20. Well, $10 plus $20 is, if we add the ones place, 0 plus 0 is 0. Then add the tens place, 2 plus 1 is 3. Our dollar sign is already there. So we know if the triangle, let's label it with a T, is scanned first, and the drum, we're going to label it with a D, is scanned second, the total cost is how much, class?
30
what?
dollars.
$30.
$30.
Make sure you use units. The cost is not 30, the cost is $30. Now, what if, in this case, the cashier scanned the drum first for $20, and then the triangle second for $10? Well, let's add place by place. Add the ones place, 0 plus 0 is 0. Add the tens place, 2 plus 1 is 3. We already have the dollar sign, so we know if the drum is scanned first and then the triangle, how much will it cost, class?
$30.
$30. So, triangle then drum is $30. Drum then triangle is $30. So does it matter what order the items are scanned in, class?
No.
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 The order in which the instruments are scanned does not change the total cost. This is the commutative property of addition. Carla, please stop messing with the camera. Focus on what we're doing, not on the camera or the things around you. Otherwise, when you go to the grocery store, it would take 700 years to check out because everybody would be trying to arrange their items in a way where it would be cheaper. But luckily, it doesn't matter what order you scan the items in, so we don't have to worry about that. So is everybody with me on commutative property of addition? Class, what is the key word when you're trying to figure out if it's a commutative property of addition problem? What is the key word, class?
Order.
Order. Okay, go ahead and turn. Okay, read in your head while I read out loud. There were 16 people at the pool on Saturday. Ooh, 16 people. That's probably going to be important. There were no people. Even though no is not a number, we still know that's important because no represents what number? Victoria? 0. How many people were there on Saturday and Sunday? Actually, on the counter. how many people were there on Saturday and Sunday. So that means if we know there were 16 on Saturday and none on Sunday, we're going to be putting them together to figure out how many people were there on Saturday and Sunday. So let's put the first piece of information first. Class, how many people were there on Saturday?
16.
16 people.
Then we need to add how many people were there on Sunday,
0.
which is how much, class?
0.
0.
0. Well, 16 plus 0. If I start with 16 and I add none, what do I end up with, class?
16.
16.
16. What property of addition does that show? We have a 16, we're adding 0, we end up with 16. What property of addition is that showing? Carla?
Identity.
The identity property of addition. Notice how in identity property of addition, the I in identity is capitalized, the P in property, and the A in addition are capitalized. That is also how you should be writing it, because it is the specific name of a property. So, class, there were how many people at the pool on Saturday and Sunday? Class?
16.
16. Remember, identity property, what's the key word that you're looking for in identity property, class? What's the key word that you're looking for in identity property of addition, class? Class?
0.
0. Come on, guys, wake up. Let's read this sentence together. Read it in your head while I read out loud. You can use properties and rules to find the unknown or missing number in a number sentence. Underline that. That's an important vocabulary word. You will be working with it for the rest of the year. The word unknown in math means a missing number. If there is an unknown in a problem you are working on in math, it means there is a missing number. Okay. Is everybody with me on the properties of addition? Be looking for those key words. Commutative, you're looking for order. You're also looking for the same add-ins, but switched, flip-flopped. In associative property, your key word is group. The symbol that you're looking for in a problem is parentheses. In identity property, the key word is 0. And what you're looking for, the symbol that you're looking for in a problem is a 0. Okay, helper number 1. Okay, so before we do example 3, let's look at the key concept box. Remember, key concept box means to memorize it. Memorize it. If you see a key concept box, memorize it, always. Memorize what it says, memorize what it's telling you, memorize the examples, whatever. So, this key concept box is about the subtraction rules. We know the subtraction rule is called zeros in subtraction. So anytime something asks you to name a subtraction rule, you're going to name it zeros in subtraction. I see like one person at school writing what I wrote. At home, I saw 2. Remember, whatever I write on the board, you write in your book. Unless I say, don't write this. If you don't hear me say anything about it, then you write it. Just because I didn't say write it doesn't mean don't write it. The only time you don't write it is if I say the words, don't write it. Okay, so the first part of the subtraction rule, tell me what it is in words, Kingston. Loud and slow. Like you're yelling.
When you subtract 0 from any number, the result is the number.
Good. So when you subtract 0, that means you're taking 0 away from a number. the answer, the result, the difference is that number that's not 0. So for example, 22 minus 0, the answer is 22. 22 is our number that is not 0 in our problem. 14 minus 0. Well, our answer, 14, is the part of our subtraction problem that is not 0. Remember, if I'm writing it on the board, you're writing it in your book. I don't have time to wait for you. So if that means you're not doing it with me, then you're going to miss part of the next thing that we do. Kingston, go ahead and read me the second part of the subtraction rule, zeros in subtraction.
When you subtract any number from itself, the result is 0.
That means you start with a number, you take that same number away, you always end with 0. We have 16 as a minuend, 16 as a subtrahend, so our answer, our difference, is going to be 0. Because if you start with 16 and you give 16 away, you end up with what? Class?
0.
What, class?
0.
0.
If you start with 20 and you give 20 away, you end up with
0.
0. So make sure you memorize these subtraction rules and these properties of addition. Now, finger or pencil on example 3. Finger or pencil on example 3. Finger or pencil on example 3. I cannot begin until everybody's finger or pencil is on example 3. Face the front. And read in your head. Find the unknown in 10 minus blank equals 10. Ooh, so we have an unknown. Remember, an unknown is a missing number. For now, we're using a box to represent the missing number. So, we're trying to figure out, okay, what goes here? 10 minus what equals 10? Please move your hand. 10 minus what is 10? Well, we know because of the identity property, the zeros in subtraction rule, when we subtract 0 from any number, the result is that number. So that means there is nothing other than 0 that we can take away from 10 to end with 10. If I start with 10 and I give you 9, do I still have 10, class?
Yeah.
If
No.
I have 10, if I have 10 apples, and I give you 9, do I still have 10 apples?
No.
No.
If I have 10 apples, and I give you 10, do I still have 10 apples?
Nope.
No.
If I have 10 apples and I give you 5, do I still have 10 apples?
Nope.
If
No.
I have 10 apples and I give you 1, do I still have 10 apples?
No.
No.
If I have 10 apples and I give you 0, do I still have 10 apples?
Yes.
Yes.
Yes, so that means the unknown is
0.
0.
Yeah.
That is the only thing that I can take away from 10 to end up with 10. So is everybody with me on properties of addition and subtraction rules? Okay, so you should be looking at the guided practice. The directions say find each unknown, draw a line to identify the property or rule used. Now, is this, how many parts do these problems have? Do they have 1 part, 2 parts, 3 parts, 4 parts? How many parts does each of these problems in the guided practice have? The answer's not here. The answer's in your book. How many parts do these directions tell you each problem has? Colin?
2.
2. The first part is find each unknown. But once you're done with that, are you done with the problems?
No.
No. Because once you finish the first part, then you have a second part. Because you also have to draw a line to identify the property or rule used. A lot of you are turning things in with only one answer to 2 and 3 part and 4 part questions. So you need to read carefully. because when you read the question carefully, it's very obvious that you need more than one answer. But if you just rush through and try to get finished, or you don't read carefully, well, then you're only going to read the first question, ignore the second question, and then lose lots of points. I will be passing something out later that will show you exactly that problem, because almost every single one of you did it. So, when you are looking at a problem, you need to figure out how many questions is it asking? How many parts are there to each answer? In this case, there are two. The first part is find each unknown. The second part is draw a line to identify the property or rule being used. So, number one, we have 19 minus blank equals 19. So we have an unknown. That unknown has to be something. What is the only number that unknown can be? Smith. 19 minus what is 19?
19 minus 0.
So the
is 19.
unknown equals
19.
not 19.
Or 0.
It's not 19 minus 19 equals 19. The unknown is
0.
0. Because the only thing that will fit there is 19 minus 0. You cannot take anything else away from 19 other than 0 to get 19. Please make sure that you are focusing. You should have already written the number 0 on that line. Now, Smith, does number 1 represent the commutative property of addition, where we switch the orders? The associative property of addition, where we have groups? Or the subtraction rule, when you subtract 0 from any number, the result is the number?
The last one. When
Which
you
is?
subtract 0 from any number, the result is the number.
Good. First of all, we know that has to be a subtraction rule because we have a subtraction symbol. Is there such thing as the identity property of subtraction, class? Or actually, raise your hand. Is there any such thing as the identity property of subtraction? Aaron?
Yes.
Did we learn about an identity property of subtraction today? So is there any such thing as an identity property of subtraction? No, there is not. When you have to answer a question about zeros and subtraction, do not tell me that the rule or the property is the identity property of subtraction, because that doesn't exist. The rule is zeros in subtraction, not the identity property of subtraction. It's zeros in subtraction. Okay, number 2, this is where we need our separate sheet of paper. So come to your separate sheet of paper. At the top, write your name, number, and date. Oops. Remember, it's September 1st, not August.
I keep doing that.
So 9/1/20. And then you're going to write page 62 through 64, because this is your separate sheet of paper for your independent practice. Not for homework, just for independent practice. Those of you at school, tomorrow when I'm checking independent practice, I'm going to be looking for this paper. If I don't see it, then you're going to have to do all the work on a separate sheet of paper during recess. So make sure you do not lose it. When I'm checking your independent practice tomorrow, I will staple this page into your math books. So does everybody understand? All your work gets shown on this separate sheet of paper. Your answers get put in the independent practice, but your work gets shown here, because for a lot of these you don't have enough room. So you're going to start. You have your name, number, and date at the top, and you have page 62 through 64. You can write IP2 to let you know, hey, this is independent practice. And then we're going to do number 2. Remember, number 2 goes to the left of your pink line. Then, next to number 2, we're going to rewrite our problem exactly as it appears. So we're going to put parentheses 5 plus the unknown. I'm just going to use a box. I'm not going to worry about shading it because that'll take too long. I'm just doing a box. Victoria, hand down, because you're thinking about your question, not following along. And then when there's a break, then you can, if you still have that question, then you can ask it. 5 plus unknown, which I did a box. I'm not shading it. That will take too long. Close parentheses. Plus 2 equals, I'm going to write the other side. 5 plus open parentheses 9 plus 2 close parentheses. Once you are finished rewriting exactly problem number 2, put your pencil down and look up. Victoria, what is your question?
Since we're not on the independent practice or on the data practice, decided to I wrote 2B.
That's fine. If you want to indicate that this is actually a guided practice problem, you can just do it right next to it, like Victoria did this. It's still mostly going to be independent practice. So you can label the top, but if you want to label that the guided practice is separate, you can go ahead and do that if you'd like. You do not have to, but you can if you'd like. Okay, so now we have to solve this problem. Well, can we solve this first side? Ethan, the front of the equal sign, can we solve this with an unknown? No, we can't. So we have to go to the other side of the equal sign. Do we have any unknowns after the equal sign, Ethan? No. So we can solve it. Remember, when we are solving a problem with parentheses, the parentheses come first. So first, we're going to put a caret underneath the 9 plus 2 in parentheses. Does everybody understand what a caret is? It's just an upside down triangle without a bottom. I like to take a whole line for my caret, and then I can put the answer in the line underneath. Now, Ethan, I need to solve 9 plus 2. What is 9 plus 2? 11. So I'm going to write that underneath my caret. My caret tells me, hey, this number plus this number equals this number. Now, underneath the 5 plus, I'm going to draw an arrow to tell me I didn't put anything together. I'm just bringing 5 plus down. Now, on my line, I should have 5 plus 11. Make sure that you are being neat. Make sure that you are fitting your numbers in one line. If you are having trouble with that, then you really need to practice your handwriting. Because the older you get, the smaller your handwriting has to get. So we're practicing making our handwriting smaller, but neater. So now, Ethan, what problem do I have left? I already figured out 9 plus, I already figured out my grouped numbers. What do I have left? Just 5? It's on your paper. What equation do I have next? Can somebody help him out? Zari?
Five plus 11.
5 plus 11, because I solved the numbers in a group. I solved the equation that's in the group. I brought down the rest, so now I have 5 plus 11. So I'm going to do another caret underneath. And Ethan, 5 plus 11 is what? 6. What is it? 16. So that means the answer to the equation after the equal sign is what? 16. That means the answer before has to be 16, right? So let's take what we have in this problem. We have 5 and 2. We know we're adding because we're doing addition. Well, 5 plus 2 equals what, Ethan? 7. Now we know we need to bring down the unknown. And we know our answer has to be 16. Well, there's only one number that the unknown can be to be 16. 7 plus what would equal 16? We can count backwards to solve it. Let's start at 16 and count how many it takes us to get to 7. 16, 15, 14, 13, 12, 11, 10, 9, 8. Oops, I started wrong. Sorry, because you don't start with 16. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7. How many did we have to count backwards to get 7? 9. So that means the unknown has to be what, Ethan? 9. Now, are we done answering number 2, Ethan? Are we? The directions say, find each unknown, which we did. Draw a line to identify the property or rule used. We found the unknown, but did we do the second part, draw a line to identify the property or rule used? So are we done? No. Okay, well, we know it's not going to be the subtraction rule, so it either has to be commutative property or associative property of addition. We see parentheses, which means we grouped. Which property tells us to group? Not commutative. Look at your anchor charts or your key concept box. Look for the word group. It's not there. Look at your anchor charts or the key concept box for properties of addition. Neither of them are on that page, Ethan. I just told you that, so that means you need to look somewhere else. Where are your anchor charts? Your anchor charts are the pages that I print out and give to you. Where are your anchor charts? Look at commutative property and look at associative property and find that key concept that you were supposed to put a box around. Find the word group. Which property has the word group? Associative. So that means this problem, we can tell by the parentheses, shows the associative property of addition. Okay, now number 3. 74 plus 68 equals unknown plus 74. Well, Michaela, what we have to do is we're going to go to our separate sheet of paper. I'm going to skip one line between the end of my last problem and my new problem. I'm going to write number 3, so you should be doing this while I'm doing it. I'm going to write number 3 to the left of my pink line, and then I'm going to copy my equation exactly as it appears next to that number 3. 74 plus 68 equals unknown plus 74. First, I need to solve 74 plus 68. Can I solve it easily sideways like this? No, so I need to set it up and down. 74 plus 68. You should only be using one line per number. Your number should not be halfway through a line. They should not be taking up 2 lines. You should have one number per line. Now we need to add. We start with the ones place. 8 plus 4, Michaela. Don't be afraid to use your fingers, class. 12. We can't put 12 in the ones place, so we have to regroup the 1 above the 10s. Now we're going to add the 10s. We're only going to add what we start with, and then we will add our regroup number. 7 plus 6, Michaela? Plus 1. We're going to write the 4 first and the 1. So that means 74 plus 68 is what? 142. That means the answer to this has to be 142. To solve this unknown, yes, I can use the property, but what if I didn't know this? Well, to solve that, I come to the side I take my sum, which is 142, and I subtract my addend that I do know. Okay? I can't do 2 minus 4, so I have to take 1 away from the tens, so that 4 becomes a, then I give it to the ones place, so that 2 becomes 12. 12 minus 4, can I do it? What is it? Use your fingers. What's 12 minus 4? 8. Now I move to the tens. 3 minus 7. Can I do it? What?
Yes.
I can take 7 away from 3? So can I do it? No. So I have to move to my hundredths and take away 1. So that 1 becomes a, and the 3 becomes a 13 minus 7. Can I do it? What is it?
No.
13 minus 7. Use your fingers. Don't try to do it in your head. That's how you make mistakes. That's why I always say, show your work.
Yes.
Michaela, we're going to start at 13 and we're going to count back 7. 13, 12, 11, 10, 9, 8, 7. So 13 minus 7 is 6. Michaela, please use your tools. Use your fingers. Count backwards. Show them. Do not try to hide them. So that means our unknown, if 142 minus 74 is 68, that means our unknown has to be, I can't hear you, 68. And this changes the order of the numbers. Which property do we know has to do with the order of numbers? The commutative property. The key word in commutative property is order. We know we also call it the switcheroo property. These addends are switched, so it has to be commutative. Okay, so that's all we have time for math now, but you will have time to do your independent practice after PE. So go ahead, leave your paper in your math book, close your math book, and put it away. For numbers 4 through 9, you're doing the same thing that you did on the guided practice. You're finding the unknown and then saying which property or rule is used. So use those key concept boxes. Remember, if it's a property, it has to be what operation? What operation has properties? Carla?
It will be associative property of.
Carla, listen to my question. Which operation has properties?
It is associative property.
That's not what I'm asking. I'm not asking you to name the properties. I'm asking which operation has properties. Smith?
Addition.
Addition. So if you see an addition symbol, you're figuring out which property. Does subtraction have properties? Zadie?
No.
No. Subtraction has what? You can go back and look. Can somebody help her out? Subtraction has what? Subtraction doesn't have properties. It has what, Zari?
Rules.
Rules. So remember, the name of the subtraction rule is zeros in subtraction. So you either need to write which property. Is it associative property? Is it identity property? Is it commutative property? Or is it zeros in subtraction rule? Ethan, you're going to have no idea what to do. You need to scoot in and pay attention. Put that down. You're not getting another one. So if you destroy that one, then that's it. Okay. So numbers 4 through 9, you're doing the same thing we did on the guided practice. You're finding the unknown, and then you are writing, is it which property it is or which rule it is. Now, look at number 10 through
19.
19. This is where you will need your separate sheet of paper, because some of them you will need to solve the way we did over here. So for numbers 4 through 9, you do not actually have to solve this way. I just did this so you can see how to solve. For numbers 4 through 9, you do not have to solve the answer. You just have to find the unknown and tell which property or rule it is. So you do not have to do all of this for number 4 through 9. Do you understand what I'm saying? You just need to look at the problem and find what's missing. Write what's missing here, and then write the property or rule. But for numbers 10 through 19, you need to solve. So you need to do all of this. For numbers, let's see, for identity properties, do you need to show work?
No.
No, because we automatically know 17 plus 0 is what class?
17.
17.
17.
Good. But what about this? Is this easy to solve up and down? Sideways? Colin?
No.
No. So you need to come to your separate sheet of paper, write number 12, write it up and down, and then solve. Don't forget regrouping. I know. And then for numbers like number 11, you need to write it this way. And solve. Okay? So does everybody understand? If it's subtraction, well, you're probably going to, but it says use properties of addition to add. So are you going to have any subtraction? No. So make sure for numbers 4 through 9, you do not have to show all this work. I just did this so you can see what to do. But for numbers 10 through 19, you do. If you don't, guess what you're going to be doing tomorrow during recess? Kingston? Colin?
We are going to be going back over and do every single problem.
Exactly.